Okay, we're going to talk about the simulator today. This is a simulator that we use for mill and lathe because this basically simulates if you're going to run a program on the machine control unit on a mill or a lathe. So we're going to run through a simulator exercise that gets you to understand how to use this. A lot safer than doing it on the mill. If something goes wrong here, it just flashes lights and beeps at you, whatever, and we don't have any crashes or unnecessary trips to the bathroom to clean out our shorts. Okay, so here we go. Going to turn it on just like you turn on a mill. Going to pull the emergency stop. Going to hit power on. And this has got a beeper. You can turn the beeper off if you want. The issue is sometimes when we're typing on this, we don't type hard enough and we don't know that it didn't get in there because it didn't beep. So this, I have to pick mill or lathe. I hit that. Now I'm going to pick mill. If I wanted to, I could go this way and it would pick lathe. But since I'm going to do a mill program, it's about the same thing as lathe. We're going to pick mill. Now we got to wait for it to do it. It says loading mill from hard drive. In other words, I'm turning myself into a mill control unit right now. So we're going to wait for that. And that's the first thing we're going to talk about here is properly power up the simulator, which I'm doing right now. It would be like properly power up the machine. After we get past all the advertisements here. All right, so now it comes up just like a mill would come up. And you know you're in mill also because we got X, Y, and Z. If we were in a lathe, we just have X and Z. But we have X, Y, and Z, 3 axes in the mill. If you see here it says alarms, 1 of 1. I'm just going to hit the reset just like I would do on a normal mill until all my alarms are cleared. Yeah, I could sit there and hit it 42 times, but when it's done, it's done. Power up restart, the blue button right next to reset. I'm going to hit that. Now it's basically simulating, sending a machine to its home position in X and Y and Z. Now if you notice, it just went black on the X and the Y because in the mind of this simulator, it actually is on tool number 1. So it doesn't have to move to the tool change position on tool number 1. So it's still, if it was in the mill, it would be way up in the air like this, the head of the machine would be. Watch my mill video on the hands-on test, it'll explain all that. So if I hit the power up restart again, it brings it down, now it blacks them all out. That means that in its mind, it has homed out X, Y, and Z. So I've properly powered up the simulator. Now, the next thing says, find drill and tap plate number 2 on the USB. Here's my USB. The USB port's on the side. Just plug that in. And I need to go to looking at the program. So I hit this button, list program. I'm in memory. And you notice, maybe you can see it, it's still blinking. That means I'm still reading the USB. Don't jump into USB until this is done blinking. Or it's like, I don't know, putting your car in gear before you got it started. Nothing's going to happen. It's going to say, I can't read it. So now that it's quit blinking, I'm going to cursor up so I can go down and get my programs in there, but I want to go where this memory's red, go over to where the USB's red, and cursor down. Whoa, I got a lot of stuff on that USB. But that's okay. To move through it quickly, I can go down one at a time or I can hit page down. That's the next page. I don't see what I'm after on there. Next page. Well, where in the devil is it, right? I know it's under CNC programs. So I can't just hit select the program because there's a bunch of them in there. I hit right enter down here and it'll open up that folder. So now I'm inside of that folder and I look and I see drill and tap plate 2.txt. If you type a program on a PC, you need to save that as a text document, .txt. If you save it as anything else, this machine can't read it. You may have a .nc, which this machine will read, but now your PC can't read that. So we do it as a .txt. I'm going to cursor down to that, hit select program. Now it has put that program into the main screen, meaning I'm going to run it. Here's the problem if I leave it like that. Somebody's running them apart, your buddy comes up, pulls it out. It just said media disconnected, FNC closed, and it went back to step plate. thanks a lot, buddy, my machine just died. So don't run off the USB unless you have to. In industry, they don't run off USB. They'll run off of a cable coming straight from a PC, an Ethernet cable. We're not doing that in this class. You can do that when you get to industry. So I'm going to go back to list program. I still have it up on my USB. I'm going to hit select, brings it up over there. I'm going to go back to list program again now. Still there. I want to put this program off USB into memory. So this is a good time to take a note because it's not on the sheet and it's not on here that tells you to do it. F2 says, oh, I want to copy to memory. If I hit that and I hit enter, it says disk done. It says bad number. That's probably a bad number in that. We're not going to worry about that. I'm going to go ahead. I just hit reset. Now, if I go back up to where this is red, over, I'm in memory, down, well, there it is. O, and it always starts with an O, 00022 drill and tap plate. I'm going to say select it. Now I'm selecting it from memory, not from the USB. Select. There it is. Now if I pull this out, no problems. You don't have to worry about your friend playing a joke on you. All right, so now I'm in memory. I now have successfully found the drill and tap plate number 2. And I have successfully put the program from the USB into the memory of the simulator. So now we need to set our offsets. So I'm going to go into offset. So this would be your offsets up here for tool and your offsets for part. Just like on a mill, I have to set a tool offset, I have to set a part offset. These offsets are not going to be as critical in here as what they would be on the machine. If I touch these off, if I touched off the tools in the machine and didn't have these in right, I'm going to physically get a crash. Here, I'm cutting out in the virtual world. I guess I have a virtual crash, but you're never going to see it. All right, so I'm going to look at the what's in the spindle. Number 1 tool is in the spindle, so it's yellow and says spindle. I'm going to follow it over. The length offset is -8. That's fine, but I'm going to go over and just change it just for the sake of changing it. So I'm going to say I need to be an inch less. 1.0, we'll add that to this number, hit right enter. Now I'm -7. Great. I'm going to do that with the next one also. I'm going to move that one by 2.2. So I'm going to say 2.2, right enter, change that one. One more time, we're going to go the other way. So now I'm going to say -0.5. So I'm going to move it down a ½ inch further. Good. So those have all changed. I'm not too worried about the rest of it. It'll work out. So here's what we got. So now it says set offsets correctly. I set that. If I hit set offset again, now I'm down here in work offset. That's my X, which would be, if I was sitting here, -15 would be this way in X. So I'm over here, and then Y is here. I've moved down negative and Y that far, and Z. I'm going to get rid of that. There should be no reason on your machine, if you're touching all your tools off on the top of your part, that you would have this -500 in there. We'll talk about that later, but there's no reason to have that in there. So I'm going to say 0.0. If I hit right enter, nothing happens. I added 0 to it. What's the point? So if I hit 0.0 and I want to overwrite what I have, I hit F1. Boom, now it's 0. So right enter adds or subtracts. F1 overwrites completely. So that's what we want to do. I'm going to do something here. If I do 0.75, now if I hit F1, you notice it's 750. Watch this. 0.7, I'll do a different, 0.1. Oh, that's not going to work. Okay, 1.0, there we go. Now if I hit F2, what happens? It made it a negative. Be careful you hit F1. If you hit F2, it makes the number, whatever you give it, a negative. You don't want it to be a negative. So again, I'm going to go 0.0 and hit F1, overwrites it, boom, we're good. So now I have set my tool offsets, I've set my machine offsets. It says, what tools does the program call out using? So let's go into memory, because we're going to be able to look at the tools now. Memory, home, reset. So I went to home, brought me to the top, reset, got rid of any errant codes that were down in here. I don't want those in there. Just get used to saying memory, home, reset every time. 2 extra buttons takes you 1 second extra, no big deal. You're not going to take anything out of your paycheck for that. All right, so first tool I have is tool number 3. If I hit T down, it's going to take me right to tool 3. Tool number 3 is a 3/8 diameter spot drill. Okay, so let's look over here. What's it say tool number 3 is? Tool number 3 is a 375 diameter. That's good. I could make that 0 and it wouldn't matter. We're not using any cutter comp moving this way or that way to offset the diameter. So it doesn't matter. I could say that's 375 and put a 6-inch diameter drill in there. The machine doesn't care because when it drills, it drills. It doesn't move left or right or up or down. It just goes straight into the part. So whatever size the tool is what hole it's going to make. So you don't have to worry about this geometry on drills or taps. It's mostly on end mills that are going to be moving in an X and Y manner. So I don't have to worry about what that says. So I'm going to go T down again. I get T5, I get a 257 F drill, 5. Well, it says 500, but I can change it just to make myself feel better. Offset, come over here to 5, come over this way. I'm over on that one now. Now notice, some machines ask for diameter, some machines ask for radius. I got a 257, that wants a radius. All right, so time to do the math. 257, half of 250 is 125, half of 7 is 3.5, so we're at 128.5. So 0.1285. So I'm going to put in 0.1285 F1, boom. Now, that's the actual radius I'm going to be drilling. But the machine could care less because it's drilling the hole. Just for sake, we put that in there. I'm going back to memory, home, reset. Now, I already did tool 3 and tool 5. So I'm just going to run on down and go to the next one. So T down, T down, T down. Oh, I got T4. Okay? If I knew that was T4, I could get there quicker. So we're going to hit home. Now, if I hit T4 down, boom. It says it's not found, which is a bunch of baloney. That's interesting. Well, make me a liar. Okay, let's try this. T4 down. Now, okay, so I did something wrong the first time. Anyway, gosh, I guess I bleed red, don't I? T4, MO6. So I called up tool 4 and it went right to tool 4. Tool 4 is a 5/16 18 tap. So I can go over here to tool 4. Well, it says it's 312.3125, which is 5/16 decimal. We're not going to care about that because, again, it's like a drill or tap. So I can just cursor down if I want, find the next tool. Tool 1. Now we're going to get into some business. Tool 1 says, what tools does the program call out and what diameter are the tools? So we're going to look at tool 1 as a 500 diameter end mill. But it says use a D value or the diameter value of a 505. So I'm going to go over here to offset, go back up to tool 1. Whoops, not that far back up. Now, half of 505 would be 252.5. So this is wrong. This is a 255. If I doubled that, it'd be 510. So we're going to hit 0.2525, and I'm going to hit F1. The reason I need to change that is if I come down on the line and I give it a tool offset, it needs to move off half the diameter. So I moved over half the diameter. We want to make sure that's right. If you get practice on doing it here, definitely practice on doing it in the machine. You can either cut too much material or not enough, and the part's either junk or you're doing it again, one of the two. So we're going to go back to memory, and I'm going to keep on going down here. That's tool 1. What's the next one? Oh, there it is, tool 2. That is a 500 diameter end mill using a D value of 500. Well, I look right over here in offset and I say that's at 250. So I'm okay on that. So what tools does the program call out using? Tool 1, tool 2, tool 3, tool 4, tool 5. What are the diameters of the tools? These up here don't matter as much other than you better make sure you load them. Don't give me a 3/8 16 tap when I want a 5/16 18. That's not going to work. So what location in the ATC are the tools? So I know what the tools are and I know where they're at. I know it's tool 1, 2, 3, 4, and 5. You need to say that's tool 2 is a 500. Rotate, call up tool number 2 when you're doing it, which I could do that. I could go into MDI, get rid of this, and I could say T2 M6, just like I do on a machine, right enter, put it up here. If I hit this button, tool change in progress, door locked, program end. I just put in a mini program and called up tool number 2. If I go back to offset, notice in the machine's brain now, it has tool number 2 in the spindle. So if the tool number 2 was empty in the tool changer, this is where I would hand jog, put it up in a click, and then load it in. So that's how I load the tools. What is the diameter compensation for each tool? Well, on the first 3, they're drills or taps. We don't care about the diameter compensation. But on those last 2, number T1 down, we have a 5/1000th diameter compensation. Number 2, we have no diameter compensation as far as being oversized or small. Now, I've got this in here. I know my tools are loaded. I knew my offsets are loaded. Everything else is great, right? Do I know that the program's actually going to run? Well, I know there's an error in here. I just saw it when we were doing stuff, so I'm going to run it and show you what happens. So I'm going to act like I'm running the program. Memory, home, reset, set graph twice. So now if I push this, and I'm not going to run the optional stop right now. Cycle start. See what happens. Okay, so now it hit an M00. That's a hard stop. I want to see. You see it's F11.111111 question mark. It says, what are you thinking here, buddy? So let's push this and see if it works. What it actually did, which is it's not really good that it did, but it did. So I'm going to go back anyway. Memory, home, reset, and go to, whoops. Oh, yeah, it worked. T4 down, that's that tap. If you see this in a machine, if you see a question mark with a whole bunch of stuff like that, you probably want to fix it. It's like, is that right? Yes, that is the feed rate I want to run at. And I have to take the threads per inch, 18. 1 divided by 18 times 200 gives me my feed rate. If your machine goes out to 3 decimal places, type in 4. Let it round it off. If it goes out to 4, type in 5. I believe a Haws goes out to 3, and it doesn't like more than that. So I'm going to type this whole line in again. N290, G84, that's tapping, Z, negative 0.9, R, 0.25, and then F, we're going to change this, 11.111, and I'm going to hit Alter. If I'm in Edit, Alter. Boom. Now it fixed it. It's all good. No question marks, no parentheses, no nothing. So the last thing I have on here, which I don't have with me, is okay. It says, check the print. What is the size of the stock? So you always want to know that, so when you actually put it in the material, you can do it. If I go back memory, home, reset, set graph, I could literally move this box. So if I said, well, I'm going to run the graphics. Well, that's hard. I can't really see what's going on there. It's kind of tight. See, it's a little tiny thing in here. If I go to F2 now F2 has a different function, zoom. Hit F2, and I say page down, I start reducing that box. And I can move it up or sideways. And I can go a little smaller, or if I go bigger. Now if I hit right enter, it locks it in. It says right, zoom done, boom. So if I hit memory, home, reset, set graph twice now, and I hit cycle start, much bigger, easier to see. Maybe you say, well, I kind of like what's going on there, but I want to see what's going on right here in this corner. So I can go back to zoom, move over there maybe, page down, get right on that corner. I can get right on it maybe, just like that, okay? Hit right enter, hit memory, home, reset, set graph, Try it again. We're looking at just that little bitty corner now. Now, on a drill and tap program, it's not that big of a deal. But if I had a radius cutting in there or something, and I wanted to really see what was going on with it, that'd be a good way to do it. All right? So that's basics on how to run a simulator. If you learn how to do this, you're one step ahead on running the machine itself. Thanks.